and the population. So measures of central tendency. In this chapter, we're going to talk about measures of central tendency and measures of dispersion. A measure of central tendency is just describing the center of our data. What's the middle? And there are different ways to look at the middle of our data, which is what we're going to focus on today. The mean is probably the most common one, the average, but we have different variables for each of these. So when we're talking about a sample, so what's the difference between a sample and a population, first of all?
It's just the whole thing, sample's just a small group.
Right. So the variable that we use for sample is x bar. And so that means it's the mean of the sample. So to find that, you just add up your values. So x1, x2, x3, and divide by the total number. So I wanted, maybe I wanted to know my average test score, but I was too lazy to do everybody. So I just took 3 people. I added up their scores, and then I would divide by 3. That's my mean of a sample, so that would be my x bar. If I want the mean of the whole population, then it's found the same way. You add up all the values and divide by the total, but the variable we use for that, it's a Greek letter. It's called mu. It looks like a U with a really long tail in front. And it's found the exact same way. You add up all your values and divide by the number of points you added up. The important thing here is that you know the difference between x bar and mu. X bar is just for a sample, mu is for the entire population. Let's do an example. So the following represent the travel times in minutes to work for all 7 employees of a startup web development company. So if you're writing this down, you don't have to write everything. We need these values. All right, is this a sample or a population? It says all 7 employees. It's a small company. They only have 7 employees. Now, if I were talking about travel time for all the teachers in our district, and I took 7 of them, that would have been a sample because it wasn't everybody. But I said it was all of them, so it's the population. So what variable do I use for the population mean? Mu. And so we just add them up. You don't necessarily have to show all the work. I'm just showing you what I'm doing. And then what would I divide by? 7, because there are 7 values. All right, so everybody find that mean. Let's round to 1 decimal. Got 24.9 minutes. Make sure if you put this in, you put parentheses around the top before you do your divide by 7. B, take a simple random sample of 3 employees. Did I tell you which 3 employees? No. So maybe I took every other one. So this time, if I'm looking at the 3, would that be a sample or a population mean?
Sample.
Sample. So that's x bar. So you add up those, and then we would divide by 3.
26.7.
If you picked a different group of 3, would you have gotten the same thing? No, probably not. So the difference is there's only one population mean, but the sample mean, depending on our sample, we could get different values back. Questions so far on the mean? The next thing that we're going to look at is the median. So the median, we use a capital M to represent that. And it's the value that lies in the middle when it's arranged in ascending order. So you put your points in order, small to large, you find the middle one. That's the median. So let's just do an example of that, see if we remember. So back to our 7 employees. If I asked for the median, can I just look at this and say, well, 18 is the middle, so that's my median? Right, has to be in order. So smallest is 5.
18, 23, 23, 26, 36.
All right, so which one's in the middle? 23 is the middle, so the median is 23. All right. Is that one okay? So let's take this same set, my same 7 employees, but we're going to hire somebody new. Okay, so now we hire an employee that has a 130-minute commute. I want to know what the mean and median are now. So the mean, this would be my population, so that's my mu. So you add them all up, and you don't necessarily have to show me this work. What are you going to add or divide by this time? Mm-hmm. $38.
And then there is no.
For our median, if I put them in order, do we have a point in the middle? So what do? The middle will be right here in between these. So what you have to do is average the points on either side to find the middle. So we have to do 23 plus 26 divided by 2.
24.5.
Okay, let's compare these to the mean and median before. What was our original population mean? So in the first example we did, our population mean was 24.9. And then I added this one employee, and my mean jumped all the way up to 38. So that was a pretty significant change, wasn't it? But let's look at the median. The original median was 23. The new median is 24.5. Did that change a whole lot? No. So here's where it comes into talking about which one's better. We saw this one, we had a large increase in the mean. But our median, we just had a small change. And this all happened because of this one point. Why would that point make such a big difference? Right. All the others are somewhat close together, but 130 is huge in comparison. Before that, our biggest was 43. This is triple our biggest value. You know, just like if I'm looking at your average test score, and if somebody was absent and I put in a 0 for that person, what does that do to the average on the test? It drops it way down. Does that number really show me how you guys performed on the test anymore? No. But when I looked at the median, even though I threw in a huge value, did it change it a lot? No. So this is a property that's called resistance. It has to do with what outliers, what really big or really small numbers do to our data. So it's resistant if extreme values do not affect its value very much. So resistant is when extreme values do not affect its value. So the median is resistant, but the mean is not. Really big or really small values. So in terms of the shape of the data, we want to use the mean to describe the center of bell-shaped data. Use the median for skewed data. So remember talking about if it was bell-shaped, skewed left, skewed right on the test, we're still going to look at that. So if it's bell-shaped, that means we have about the same number of high values and low values to balance each other out. So the mean will give you the best picture of that center. But if it's skewed, that means we either have a lot of really high values or a lot of low values. It's going to affect the mean. So we would look at the median there. All right, so I have a chart we're going to kind of look at. These are the three cases. We know we can have skewed left, bell-shaped, and skewed right. Okay, so if it's skewed left, the mean, when you have more low values, it drags the mean, the average, down. And so when it's skewed left, that means your mean is going to be smaller than the median. Skewed left, you have a lot of low values, so it will drag your mean down. If it's symmetric, bell-shaped data, the mean and the median should be the same, or very, very close to it. In real data, a lot of times it's not perfect, but they should be close to each other. If it's skewed to the right, that means we have more high values. So what that's going to do is drag your mean up. So when it's skewed right, the mean is going to be bigger than your median. You might jot yourself a few notes here. One of your homework questions gives you the mean and median and asks you, is it going to be symmetric, or is it skewed left or skewed right? And what you're looking at there is, which one's bigger? Is the mean bigger or is the median bigger? Okay, so the mode is the most frequent observation. Which one happens the most often? Yeah, in that set of the commute times, my mode would have been 23 minutes because it showed up twice. You could have more than one mode. So if I had two different values that both showed up 3 times, then they could both be in mode. If everything just showed up once, there isn't anything that is the most frequent, so there is no mode. So we don't have to have one, and there could be more than one when we're looking at the mode. looking at these things, we can find mean, median, and mode by hand. But if we have a large data set, that's really not the best option. We want to be efficient with our time, so we're going to use the calculator a lot when we're doing these things. So I have a set of values, and we are going to enter them on our calculator. Okay, so this is giving me the price of homes. When you put this in, we're going to put it in L1. So remember, don't delete out the list. That causes a lot of problems. So if you go to Stat, Edit, if you have stuff on L1, if you just go up to the title and hit Clear, Enter, it takes everything out. Then put all of these values in L1. So now if you go to Stat, go over to Calculate, and we want the first thing, one variable statistics. Okay, make sure your list is set on L1. Does everybody's list say L1? Frequency list, don't worry about that. Calculate, just hit enter. And so it comes up with a list of stuff for me. So if I ask you for the mean of this data set, the mean is X bar, so that's $123,193.37.5. Okay, so it gives us the mean. It has a whole list of information here. We haven't talked about a lot of this stuff yet. But if you look, the median, it calls it MED, so it also gives you the mean. Okay, you just have to scroll down to that. If you go through your list, it does not tell you the mode. So if I ask for mode, you have to find that yourself. But it will give you the mean and the median. Now if I asked you to identify the shape based on this. So my median is 127,925. My mean is 123. So my mean is smaller than my median, right? So if we look back at what we wrote down, when the mean is smaller, that meant we had low values that drug that mean down. So this data set is skewed left. It's got more low values than high values in it. All right. Is that okay with everyone? You could also do a histogram if you wanted to compare that. I'm not going to, and I wouldn't require you to on the homework, but that's just another tool because we have talked about those before. Remember those bar graphs that we make on our graphing calculator? You could look at it to check your shape. All right, let's look at this one. So a set of data includes the values 11, 15, blank, 24, 29, 31. If the median is 20.5, what is that missing value? So I gave you the set. I'm trying to figure out what this value is right here. What's the median? It's 20.5. We find the median by finding the middle. So these are in order. The middle would be right here. So if it's not an actual value, what do you have to do with it? What did we? So that means whatever that missing value was, plus 24 divided by 2 equal 20.5. Is this an equation you could solve? Yeah, multiply over your 2. Divide or subtract your 24. And we get a missing value of 17. let's see, is this one okay? I'm going to do a book problem. So if you have somebody with a book near you, 129, page 129, let's look at number 32. Sorry, you're going to need to bring your books for the next few days. I don't think I have any more extra ones. Yeah, okay, how about this? I will read this to you, but then you're going to have to go to your lockers to get your book for homework. Sorry, I meant to tell you guys last week to bring them today, and I forgot. All right, so this one says, Mr. Zero finds the mean height of all 14 students in his statistics class to be 68.0 inches. So his mean is 68.0, and we have 14 students. Just as Mr. Zero finishes explaining how to get the mean, Danielle walks in late. Danielle is 65 inches tall. What is the mean height of the 15 students? So, I want to know what's the new average height. But the problem is, did I give you the original 14? No. So how do I figure it out? Think about, how did I find this mean to begin with? Alright, so I added up all 14, so let's just call that x. I divided by 14, and it equaled 68. So if I want to solve for x, we can multiply over that 14. So we get 952. This is the sum of the 14 heights. So to get the new average, you would have to add up all 15 of them, right? Well, the first 14 add up to 952, plus my new value is 65, and now I divide by 15. So our new height is 67.8. So what did she do to our mean?
She
Made it go down. By a little or a lot?
a little bit.
A little bit. So she probably wasn't an outlier. She was pretty well consistent with everyone else. Okay, is this all right with everybody? Okay, so I'm done. So if I don't really want to send the whole class to get a book, but if maybe you could share with somebody, so like, you know, if there's two of you staying close together, if one of you wants to go get your book, here is your assignment. And